Okay, in this video, we're going to look at core DNS and Kubernetes. So the first question is to identify the DNS solution implemented in this cluster. So let's set my alias, k equals kubectl, and let's do get pods -n kube system. We see all the pods in the kube system namespace, and we see that we have the core DNS pods. So these are so we use core DNS as the DNS solution. Okay, the next question is how many pods of the DNS server are deployed? So we see that there are 2. So that's the answer to that. There are 2 pods. Now, what is the name of the service created for accessing core DNS? So the name of the service created for accessing core DNS. So let's do a service that as we see in the kube system namespace. And we see that there's only one service called kubedns. So that's the service that's used for accessing the DNS server. So that is kube-dns. Now, what is the IP of the core DNS server that should be configured on the pods to resolve services? So all the pods should have the IP of the core DNS service, and that IP is 10.96.0.10. So that's the IP of this service. So that's this one. Now, where is the configuration file located for configuring the core DNS service? So let's look at the core DNS service. Let's do a system. We see that we have these 2 pods. So let's take a closer look at those pods. Do a describe pod in the kube system namespace. And we see additional information, and here is the container that runs the core DNS service, and it's this is the image that runs the core DNS 1.7.0, and these are the ports that are exposed. But here, if you look at here, these are the arguments that are passed to the core DNS container. So the config file is at /etc/core-DNS/core file. So that's etc core DNS core file. So that's the configuration file. Now, how is this core file passed into the core DNS pod? So is it pulled from Git when it starts, or is it configured as a config map object? Does it come built in, or is it stored on the master node? So if you look at this, the path etc core DNS, let's see if there are any mounts. So there are mounts. So we have a etc core DNS mount, and it says that it is coming from config volume. And we can also see this if we do, so let's say we do a kubectl get pod, and we look at it in the YAML format. So if you look at it this way, let's go up. Okay. So this is the spec section. So you can ignore all of this. Always look at the spec section, and we have the container. So for the container, we have the arguments that we just saw, the image and everything. If you scroll down, you'll see the volume mounts. So you have volume mounts here, and the etc core DNS is the volume mount, and is coming from a config volume. And so if you have volume mounts, then you have volumes. So you scroll down and we see volumes. So this is where the volumes are configured. And the volume for config mount is the config volume. And here you see you have the core file and core DNS. Core DNS is the config volume. So config map. So this is what indicates, this is what tells us that it's loaded from a config map. Okay, so the next question is, what is the name of the config map object created for core file? So for this volume, this config map, the name of the config map is core DNS. So that's the name of the config map. Now, what is the root domain or zone configured for this Kubernetes cluster? So to find that out, we have to look into that config map. So let's do that now. So let's do a get config map in the kube system namespace. So we have the core DNS. So let's do a describe config map in the kube system namespace. These are the DNS config for Kubernetes, and right here, this is the root. This is the root domain. So that's cluster.local. Now we have deployed a set of pods and services in the default and payroll namespaces. So inspect them and go to the next question. All right, so let's do that. So let's look at get pods, and we see that there are indeed the HR, the simple web app, and test. So there are 4 pods, and then there's also another namespace called payroll. And in the payroll namespace, there's another application called web. Right, so there are multiple applications, so that's fine. Now, what name can be used to access the HR web server from the test application? So here we have the HR web server, and here we have the test application. So we want to access the HR web server from the test application. So you can execute the curl command, or you can test applications also have a UI. So let's use the UI. I like the UI. This is the UI of the test application, and we'll use this to run a connectivity test. But first, how do you access the HR application, right? So if you do a HR, and assuming it's on 8080, it's not working. So we have to find out what is the service that's used to access this. So let's do a kubectl get svc, because that's in the default namespace. And we see that there are multiple services. You have the test service and the web service. I'm assuming the test service is for the test application, and I'm not sure if the web service is for the HR application. So let's do a describe on the web service. Service is missing. SVC. And we see that the selector here, name equals HR. Right? So that indicates that the web service is a service for the HR application. So that's what connects them to. So it's web service. So I'm going to use web service, and the port, if you see, is 80. So that's what I'm going to do. So I'm going to use web service and the port 80. And let's run a test. Okay, so it says this is the HR server. So that's good. So that confirms that. So it's web service. That's what is the answer to this question. Okay, now which of the names cannot be used to access the HR service from the test pod? So we know that to access the HR service from the test pod, we just used web service. That works. Does web service.default work? It will, because we are in the default namespace. So let's try that. Default. Yep, so that works. Does web service.default at SVC work? But SVC. Yes, because SVC stands for service, and web service is a service in the default namespace. So that's fine. The next one is web service.default.pod. So let's try pod. So that fails. So that's not the right kind of convention. So this is the right answer to this question. Now, which of the below name can be used to access the payroll service from the test application? So the payroll service, as we know, it must be in the payroll namespace, right? So let's explore that. Let's do a kubectl get pod payroll. And then, so there's a web service there. And then let's do a get svc -n payroll. And we see a web service here. So this is, let's make sure that this is for that. So let's do a kubectl describe svc web service in the payroll service, in the payroll namespace. It's 10e. Okay, and we see that the selector is name equals web app. So that's for this. So yes, the web service is used for the web application in the payroll service. So in the payroll namespace, so we'll just assume that this is the payroll service. So which of the below name can we use to access the payroll service from the test application? So the test application we know is in the default namespace. So if you do a web service from the default namespace, it's going to go to the HR app. That's not what we want. We want to access the web service in the payroll namespace. So the web is not the correct answer. Web service.default is going to go to the HR app, web service.payroll, because it's in the payroll namespace. So let's try that. And it says this is a payroll server. Yep. So it's web service.payroll. So that's the answer to this question. Now, which of the below name cannot be used to access the payroll service from the tests application? So web service.payroll, we know it works. Web service.payroll.svc.cluster. So payroll.svc.cluster. So that doesn't work because it should either be web service.payroll, or it should be web service.payroll.svc, or it should be web service.payroll.svc.cluster.local, because cluster.local is the root domain, the root zone. So you should either use cluster.local, or you shouldn't use anything at all. So cluster is something that doesn't work. Now we just deployed a web server web app that accesses a database MySQL server. So let's check that out. kubectl get deployment. And we see that there's a web app, indeed. And then it accesses a database, a MySQL server. However, the web server is failing to connect to the database. So we don't see a MySQL server here. So let's do a kubectl get pods and all namespaces, so we can see all the pods. So we can ignore most of these. But if you look at these two, so there are two namespaces, and we have the web app, the pod that runs the web app. So it says web app, so this is web app. So this is our application. And if you look here, we have the MySQL database here, so it is in the payroll. Hello and welcome to this lecture. My name is Mumshad Manambat, and we are going through the Kubernetes certification course. And in this lecture, we will discuss about ingress in Kubernetes. Before we proceed, please remember to subscribe to our channel so that you know when our new videos come out. We will start with a simple scenario. You are deploying an application on Kubernetes for a company that has an online store selling products. Your application would be available at, say, my-online-store.com. You build the application into a Docker image and deploy it on the Kubernetes cluster as a pod in a deployment. Your application needs a database, so you deploy a MySQL database as a pod and create a service of type cluster IP called MySQL service to make it accessible to our application. Your application is now working. To make the application accessible to the outside world, you create another service, this time of type node port, and make your application available on a high port on the nodes in the cluster. In this example, a port 38080 is allocated for the service. The users can now access your application using the URL http://IP of any of your nodes, followed by port 38080. That setup works and users are able to access the application.
Whenever traffic increases, we increase the number of replicas of the pod to handle the additional traffic, and the service takes care of splitting traffic between the pods. However, if you have deployed a production-grade application before, you know that there are many more things involved in addition to simply splitting the traffic between the pods. For example, we do not want the users to have to type in the IP address every time. So you configure your DNS server to point to the IP of the nodes. Your users can now access your application using the URL myonlinestore.com and port 38080. Now, you don't want your users to have to remember port number either. However, service node ports can only allocate high-numbered ports which are greater than 30,000. So you then bring in an additional layer between the DNS server and your cluster, like a proxy server, that proxies requests on port 80 to port 38080 on your nodes. You then point your DNS to this server, and users can now access your application by simply visiting myonlinestore.com. Now, this is if your application is hosted on-prem in your data center. Let's take a step back and see what you could do if you were on a public cloud environment like Google Cloud Platform. In that case, instead of creating a service of type node port for your where application, you could set it to type load balancer. When you do that, Kubernetes would still do everything that it has to do for a node port, which is to provision a high port for the service. But in addition to that, Kubernetes also sends a request to Google Cloud Platform to provision a network load balancer for this service. On receiving the request, GCP would then automatically deploy a load balancer configured to route traffic to the service ports on all nodes and return its information to Kubernetes. The load balancer has an external IP that can be provided to users to access the application. In this case, we set the DNS to point to this IP, and users access the application using the URL myonlinestore.com. Perfect. Your company's business grows, and you now have new services for your customers. For example, a video streaming service. Now, you want your users to be able to access your new video streaming service by going to myonlinestore.com/watch. You'd like to make your old application accessible at myonlinestore.com/where. Your developers developed the new video streaming application as a completely different application, as it has nothing to do with the existing one. However, to share the cluster's resources, you deploy the new application as a separate deployment within the same cluster. You create a service called video service of type load balancer. Kubernetes provisions port 38282 for this service and also provisions a network load balancer on the cloud. The new load balancer has a new IP. Remember, you must pay for each of these load balancers, and having many such load balancers can inversely affect your cloud bill. So how do you direct traffic between each of these load balancers based on the URL that the user types in? You need yet another proxy or load balancer that can redirect traffic based on URLs to the different services. Every time you introduce a new service, you have to reconfigure the load balancer. And finally, you also need to enable SSL for your applications, so your users can access your application using HTTPS. Where do you configure that? It can be done at different levels, either at the application level itself, or at the load balancer level, or at the proxy server level. But which one? You don't want your developers to implement it in their applications, as they would do it in different ways. And it's an additional burden for them to develop additional code to handle that. You want it to be configured in one place with minimal maintenance. Now, that's a lot of different configuration, and all of these becomes difficult to manage when your application scales. It requires involving different individuals in different teams. You need to configure your firewall rules for each new service, and it's expensive as well, as for each service, a new cloud-native load balancer needs to be provisioned. Wouldn't it be nice if you could manage all of that within the Kubernetes cluster and have all that configuration as just another Kubernetes definition file that lives along with the rest of your application deployment files? That's where Ingress comes in. Ingress helps your users access your application using a single externally accessible URL that you can configure to route traffic to different services within your cluster based on the URL path, at the same time implement SSL security as well. Think of Ingress as a layer 7 load balancer built into the Kubernetes cluster that can be configured using native Kubernetes primitives, just like any other object that we've been working with in Kubernetes. Now remember, even with Ingress, you still need to expose it to make it accessible outside the cluster. So you still have to either publish it as a node port or with a cloud-native load balancer. But that is just a one-time configuration. Going forward, you're going to perform all your load balancing, auth, SSL, and URL-based routing configurations on the Ingress controller. So how does it work? What is it? Where is it? How can you see it? And how can you configure it? And how does it load balance? How does it implement SSL? Without Ingress, how would you do all of these? Well, I would use a reverse proxy or a load balancing solution like Nginx or HA proxy or Traffic. I would deploy them on my Kubernetes cluster and configure them to route traffic to other services. The configuration involves defining URL routes, configuring SSL certificates, etc. Ingress is implemented by Kubernetes in kind of the same way. You first deploy a supported solution, which happens to be any of these listed here, and then specify a set of rules to configure Ingress. The solution you deploy is called as an Ingress controller, and the set of rules you configure are called as Ingress resources. Ingress resources are created using definition files like the ones we have been using to create pods, deployments, and services earlier in this course. Now remember, a Kubernetes cluster does not come with an Ingress controller by default. If you set up a cluster following the demos in this course, you won't have an Ingress controller built into it. So if you simply create Ingress resources and expect them to work, they won't. Let's look at each of these in a bit more detail. As I mentioned, you do not have an Ingress controller on Kubernetes by default, so you must deploy one. What do you deploy? There are a number of solutions available for Ingress, a few of them being GCE, which is Google's Layer 7 HTTP load balancer, Nginx, Contour, HA proxy, Traffic, and Istio. Out of these, GCE and Nginx are currently being supported and maintained by the Kubernetes project. And in this lecture, we will use Nginx as an example. These Ingress controllers are not just another load balancer or Nginx server. The load balancer components are just a part of it. Ingress controllers have additional intelligence built into them to monitor the Kubernetes cluster for new definitions or Ingress resources and configure the Nginx server accordingly. An Nginx controller is deployed as just another deployment in Kubernetes. So we start with a deployment definition file named Nginx Ingress controller with one replica and a simple pod definition template. We will label it Nginx Ingress, and the image used is Nginx Ingress controller with the right version. This is a special build of Nginx built specifically to be used as an Ingress controller in Kubernetes. So it has its own set of requirements. Within the image, the Nginx program is stored at location /Nginx Ingress controller. So you must pass that as the command to start the Nginx controller service. If you have worked with Nginx before, you know that it has a set of configuration options such as the path to store the logs, the keep alive threshold, SSL settings, session timeout, etc. In order to decouple this configuration data from the Nginx controller image, you must create a config map object and pass that in. Now remember, The config map object need not have any entries at this point. A blank object will do. But creating one makes it easy for you to modify a configuration setting in the future. You will just have to add it into this config map and not have to worry about modifying the Nginx configuration files. You must also pass in two environment variables that carry the pod's name and namespace it is deployed to. The Nginx service requires these to read the configuration data from within the pod. And finally, specify the ports used by the ingress controller, which happens to be 80 and 443. We then need a service to expose the ingress controller to the external world. So we create a service of type node port with the Nginx ingress label selector to link the service to the deployment. As mentioned before, the ingress controllers have additional intelligence built into them to monitor the Kubernetes cluster for ingress resources and configure the underlying Nginx server when something is changed. But for the ingress controller to do this, it requires a service account with the right set of permissions. For that, we create a service account with the correct roles and role bindings. So to summarize, with a deployment of the Nginx ingress image, a service to expose it, a config map to feed Nginx configuration data, and a service account with the right permissions to access all of these objects, we should be ready with an ingress controller in its simplest form. Now on to the next part of creating ingress resources. An ingress resource is a set of rules and configurations applied on the ingress controller. You can configure rules to say, simply forward all incoming traffic to a single application, or route traffic to different applications based on the URL. So if the user goes to myonlinestore.com/where, then route to one app. Or if the user visits the watch URL, then route the user to the video app. Or you could route user based on the domain name itself. For example, if the user visits where.myonlinestore.com, then route the user to the Where app, or else route the user to the Video app. Let us look at how to configure these in a bit more detail. The ingress resource is created with a Kubernetes definition file, in this case, ingresswhere.yaml. As with any other object, we have API version, kind, metadata, and spec. The API version is extensions /v1 beta 1. Kind is ingress, and we will name it ingresswhere. And under spec, we have backend. Now remember that the API version for ingress is extension /v1 beta 1 as of this recording, but this is expected to change with newer releases of Kubernetes. So when you are deploying ingress, always remember to refer to the Kubernetes documentation to know exactly the right API version for that release of Kubernetes. So the traffic is, of course, routed to the application services and not pods directly. The backend section defines where the traffic will be routed to. So if it's a single backend, then you don't really have any rules. You can simply specify the service name and port of the backend where service. Create the ingress resource by running the kubectl create command. View the created ingress by running the kubectl get ingress command. The new ingress is now created and routes all incoming traffic directly to the where service. You use rules when you want to route traffic based on different conditions. For example, you create one rule for traffic originating from each domain or hostname. That means when users reach your cluster using the domain name myonlinestore.com, you can handle that traffic using rule 1. When users reach your cluster using domain name where.myonlinestore.com, you can handle that traffic using a separate rule, rule 2. Use rule 3 to handle traffic from watch.myonlinestore.com, and say use the fourth rule to handle everything else. And just in case you didn't know, you could get different domain names to reach your cluster by adding multiple DNS entries, all pointing to the same ingress controller service on your Kubernetes cluster. Now within each rule, you can handle different paths. For example, within rule 1, you can handle the where path to route that traffic to the clothes application. and a watch path to route traffic to the video streaming application, and a third path that routes anything other than the first two to a 404 not found page. Similarly, the second rule handles all traffic from where.myonlinestore.com. You can have path definition within this rule to route traffic based on different paths. For example, say you have different applications and services within the apparel section for shopping, or returns, or support. When a user goes to where.myonlinestore.com, by default they reach the shopping page. But if they go to exchange or support URL, they reach a different backend service. The same goes for Rule 3, where you route traffic to watch.myonlinestore.com to the video streaming application, but you can have additional paths in it, such as movies or TV. And finally, anything other than the ones listed here will go to the fourth rule, that would simply show a 404 not found error page. So remember, you have rules at the top for each host or domain name, and within each rule, you have different paths to route traffic based on the URL. Now let's look at how we configure ingress resources in Kubernetes. We will start where we left off. We start with a similar definition file. This time under spec, we start with a set of rules. Now our requirement here is to handle all traffic coming into myonlinestore.com and route them based on the URL path. So we just need a single URL for this, since we are only handling traffic to a single domain name, which is myonlinestore.com in this case. Under rules, we have one item, which is an HTTP rule in which we specify different paths. So paths is an array of multiple items, one path for each URL. Then we move the backend we used in the first example under the first path. The backend specification remains the same. It has a service name and service port. Similarly, we create a similar backend entry to the second URL path for the watch service to route all traffic coming in through the watch URL to the watch service. Create the ingress resource using the kubectl create command. Once created, view additional details about the ingress resource by running the kubectl describe ingress command. You now see two backend URLs under the rules and the backend service they are pointing to, just as we created it. Now, if you look closely in the output of this command, you see that there is something about a default backend. What might that be? If a user tries to access a URL that does not match any of these rules, then the user is directed to the service specified as the default backend. In this case, it happens to be a service named default HTTP backend. So you must remember to deploy such a service. Back in your application, say a user visits the URL myonlinestore.com/listen or eat, and you don't have an audio streaming or a food delivery service, you might want to show them a nice message. You can do this by configuring a default backend service to display this 404 not found error page. The third type of configuration is using domain names or host names. We start by creating a similar definition file for ingress. Now that we have two domain names, we create two rules, one for each domain. To split traffic by domain name, we use the host field. The host field in each rule matches the specified value with the domain name used in the request URL and routes traffic to the appropriate backend. In this case, note that we only have a single backend path for each rule, which is fine. All traffic from these domain names will be routed to the appropriate backend irrespective of the URL path used. You can still have multiple path specifications in each of these to handle different URL paths. Now let's compare the two. Splitting traffic by URL had just one rule, and we split the traffic with two paths. To split traffic by hostname, we used two rules and one path specification in each rule. Well, that's it for this lecture. Let us now head over to the practice test section and practice working on ingress. Now there are two types of labs in this section. The first one is where an ingress controller, resources, and applications are already deployed, and you basically view and walk through the environment. The first one is where an ingress controller, resources, and applications are already deployed, and you basically view and walk through the environment, gather data, and answer questions. Towards the end, you would create or modify ingress resources based on the needs. In the second practice test, you will be deploying an ingress controller and resources from scratch. Well, good luck and hope you enjoy the labs. I will see you in the next lecture.
Okay, so let's go through this lab on the ingress controller. So we have deployed ingress controller resources and applications to explore the setup. So let's first look at the environment. So let's look at the nodes. There's a single node. Let's look at the deployments. So there are no deployments. Let's check all namespaces. So there are deployments in other namespaces. So there are deployments in the app space, the Ingress Nginx space, the Cube system space. Let's look at the Ingress controller, which is usually in Cube system namespace. Let me see. Nope, it's in the Ingress namespace, which is, sorry, it's given here. So it's Ingress Nginx. And yeah, well, so we see the Ingress controller and the other pods right here. Okay, so which namespace is the Ingress controller deployed in? So if you run a get pods-a command, we see all the pods and we see the Ingress controller here, and we see that it's part of the Ingress Nginx namespace. So it's the Ingress Nginx namespace. Now, what is the name of the Ingress controller deployment? So the Ingress controller deployment, this is the name of the deployment. So we can also verify that, but by doing a get deploy in the Ingress Nginx namespace, and we see that it's Ingress Nginx controller. So it's Ingress Nginx controller. Now, which namespace are the applications deployed in? So we have, so here we have the pods for the application, and we have the video where and the default backend application. They're in the app space namespace. How many applications are deployed in the app space namespace? So we see that there are 3 pods, so that's 3 applications. Now, which namespace is the Ingress resource deployed in? So let's look at the Ingress resource. So we'll do a cuddle get Ingress, and we'll look at all namespaces, and we see that we have the Ingress where watch resource, and it's in the app space namespace. Now, what is the name of the Ingress resource? So the name of the Ingress resource is Ingress where watch. Now, what is the host configured on the Ingress resource? So you can see that right here. So it's set to star. That means all hosts are applicable, or all or any hosts. What backend is the where path on the Ingress configured in? So let's look at the Ingress where watch Ingress resource in a bit more detail. So that's in the app space namespace. And here we see the additional details, and we can see the rules. We see the host, and then we see the path. We have the where and the watch path, and what backend is the where path configured to. So the where path is configured to the where service. So that's the where service. At what path is the video streaming application made available on the ingress? So the video streaming application, the video service, is at the watch path. So watch is the answer. If the requirement does not match any of the configured paths, what service are the requests forwarded to? So we know that if it does not match any of these, it's going to go to the default backend. So here it is default HTTP backend. That's the service. So that's default HTTP backend. Now view the ingress service using the tab at the top of the terminal. So here we have ingress service. And if you look at it, it gives us a 404 not found error. So which page do you see? So we see a 404 error page. Now view the applications by appending the where and watch to the URL that you opened. So let me open this. And we have a where, which is this. So this is the where application, and then we have the watch. This is apparently this is the video streaming application. Okay. Now you're requested to change the URLs at which the applications are made available. So make the video streaming application available at stream. So for that, let's go and edit the ingress resource. So let's just replace describe with edit. And this one should be fairly easy. So here we have the paths. So we have the where path for the where service, and then we have the watch path for the watch service. So all we have to do is replace this with stream. And let's save that. So it's immediately replaced. So if we refresh the watch path, now we get a 404 error. And we replace it with stream, and we now get the video streaming application. So let's check that out. Yep, so that's successful. Now view the video application using the stream, which we already did. So let's skip that. Now a user is trying to view the eat URL on the ingress service. Which page would he see? So we know that there's nothing called eat. So let's just verify. So there's nothing called eat here, but we don't know if it is there in another space. So let's try that out. Eat. So it doesn't, there's nothing, so it's a 404 error. So there's a 404 error. Now, due to increased demand, your business decides to take on a new venture. You acquired a food delivery company. Their applications have been migrated over to your cluster. So inspect the new deployments in the app space namespace. Okay, so let's check out deploy in the app space namespace. We see that we have the default backend, we have food along with the video and where application. So this is the new application. Now you're requested to add a new path to your ingress to make the food delivery application available to your customers. So make the new application available at eat. So we want to make it available at eat. So we know that we need to find out the service that this is exposed on. So let's try and find that. So instead of deployment, let's look at services in the same namespace. And we see that we have the food service, and let's also verify and make sure that the port is 8080. So it's food service at port 8080. So I'm going to copy that, and let's go and edit the ingress resource again. So we have a command for that already. Kubectl edit ingress, the name of the ingress resource in the app space. And all we need to do is add an additional path here. We're going to copy this, paste that, and what we'll do is, we know that it's food service, so food service, and the port number is 8080, that's fine, and the path is eat, and let's save that. Let's wait for it to finish. Okay, and let's try and refresh, and we see the food service application. Okay, let's check the work. Okay, now view the food delivery application using eat, which we already did. Now a new payment service has been introduced. Since it is critical, the new application is deployed in its own namespace. So identify the namespace. Okay, so let's do a get pods -a and see what that new namespace is. So we have a new namespace called critical space. So let's do a get deploy in the critical space. And we see that we have a web app pay. So this is the new deployment. So identify the namespace. So that's critical space. What is the name of the deployment of the new applications? We just found that out. It's called web app pay. You're requested to make the new application available at pay. So identify and implement the best approach to making this application available on the Ingress controller and test to make sure it's working. Look into annotations as well. Okay, so we know that for the app space applications, we have the Ingress resource in the app space. Now we cannot use that resource to add something in another space. So what we're going to do is we're going to create an Ingress resource for this critical space itself. So, or at least that's the best practice. The best practice is to create for different teams who may be having access to different namespaces to create their own Ingress resource, right? So that should be the approach that we should be using. So you can assume that maybe those who are working on this application only has access to this namespace, but those who are working on the WebPay application only has access to this namespace. And so any Ingress related resources that are created would have to be created in this namespace. So we'll create a new ingress, and then we'll set the path as we did before. We'll set the backend service. So let's first find out what the backend service is to this web pay. So it's called pay service. So just like food service, where service, this one is called pay service, and the deployment is web app pay. So we want to direct traffic that goes to the path pay, which as of now, there won't be anything. And we want to direct that to this pay service on port. So remember that the port now is 8282. So that should be the port. Okay, so let's do a kubectl create ingress. And so we do have an imperative command for that. Let's do a -h to see the format. So we're going to, there are multiple examples, and let's just pick the simplest one, right? So kubectl create ingress, the name, and then the rule. And that's basically it. So let's do that. So the name, let's see if there's a name given. So there's no name given here. So we could, give it any name. So this is going to be ingress pay, maybe. And then it's in the namespace. Remember that this has to be in the critical space. And then the rule is that anything that goes to, pay, the path pay, so that's pay here, would go to the pay service. That's what we just saw. And the port is 8282. And we don't have any certs for now, so let's just get rid of this. So that's the ingress pay. So let's check it out. Get ingress in the critical space. And we see that it's indeed created. Let's take a look at it. Ingress in critical space. And we see that we have the ingress pay is going to catch everything that goes to pay and then redirect that to pay service, right? So let's go and try it out here. But you see that it's not working as expected. Still gives the 404 error. So let's take a look at the logs and find out why. So if you look at the logs of this application in the critical space, so we have the web app pay service, so the web app pay pod. Then what we're going to do is we're going to do a logs for that pod in the critical space, and we see that these are the requests that are coming in. It's coming in as pay, right? So the thing is, these applications may not have a /pay at the end, right? So it should be without this pay. So what's happening is when you're calling pay, is just the ingress resource is just forwarding as is, the URL as is, to this application, and this application does not really have a pay path. So it should just be just slash, right? So let's do that. So for that, we have to put in the ingress, the annotations, and the rewrite rules. So if you look at this, right, the watch, where, or even the pay service, they're just available at this. They don't have a /watch or /where at the end. But with the default rule that the ingress controller creates, anything that goes to watch is going to have watch at the end, and anything that goes to where is going to have where at the end. So that's why the error. So we want to put in this rewrite annotation to get that removed. So let's copy that, and let's edit the ingress pay in the vertical space. We should have ingress, and then so we've got to add an annotation here. So annotations go in metadata section here, and we're going to set a rewrite target. So this is basically going to take that out and take out the pay at the end, and then just put slash there. So that seems to be set. Okay, so when you refresh it, you can actually see that this is working as expected. Okay, let's check our work. That's good. And yeah, we've already gone here and verified that it's working. Okay, so that's the end of this lab. Hey, in this video, we're going to look at ingress networking in a bit more detail. So I will try and deploy an ingress controller. So we've deployed two applications, explored the setup. So let's check that out. Set alias first. Let's do a pause -a. Here we have, in the app space, we have the video and the where applications. So let us now deploy an ingress controller first. So create a namespace called ingress space. So let's so this is what we're going to do. The first step is to create this namespace called ingress space. So we'll do this one step at a time. So let's do that first. Create namespace ingress space. Okay, so that's successful. Now the Nginx ingress controller requires a config map object. Create a config map object in the ingress space. So we're just going to create a config map object. So we'll do a kubectl create config map in this, and the name should be as given here, Nginx configuration, and the namespace is ingress space. Okay, so that's done. So if you can see here, so we've just created these two. Now the Nginx ingress controller requires a service account. So create a service account in the ingress space name. The name of the service account is ingress service account. So create service account in the ingress space. Okay. We've created the roles and role bindings for the service account, so let's check that out. Okay, so get roles. So we have the ingress role and role bindings. We have the ingress role binding. Let's check out ingress role in the ingress space. So we see that there are a number of resources that are given access to, like the policy secrets, namespaces, and these are the verbs that the actions that it can perform. Okay, let's keep going. Let us now deploy the ingress controller. Create a deployment using the file given. So there's already a file given called ingress controller.